So what we want to think about for this is kind of like if you're solving any equation that's got a fraction in it, the first thing that you would do typically is clear out the fraction. It depends a little bit on what it looks like, but first thing you want to do is clear out the fraction. And for sure, when you have an x on the bottom, you've got to get that x into a numerator somewhere. So what we're looking at, similar to adding and subtracting rational expressions, we're going to look at common denominators and that kind of thing. But we're not adding and subtracting, so the execution's a little bit different, but the idea is kind of similar, kind of the same. Okay, so let's take a look at the first one. It only has one denominator. So effectively what I'm going to do is multiply both sides of the equation. With rational expressions, you multiply the top and the bottom, right? Because it's just like fraction math. But in this case, it's an equation, so I'm going to multiply both sides of the equation by x plus 3 and x plus 3, the denominator. So x plus 2 over x plus 3 equals x plus 3 times 2. Okay, and on this side, they divide to 1. That gives us an exception. If x was negative 3, then I would have just divided by 0. I'd be dividing by 0 in the beginning. That wouldn't work. But this is a different kind of exception. So we're going to write it down. We're going to make a note of it. But when I finish this question, so let's finish it. The rest of this is just a linear equation, grade 9 stuff, super simple. Okay, so subtract 2x from both sides, I get negative x. Subtract 2 from both sides, I get 4, and x equals negative 4. Does that look good? So x isn't negative 3. Like our restriction said, x can't be equal to negative 3. Well, it's not. Negative 3 doesn't balance this equation anyway. Put negative 3 into the top and bottom and you won't get 2. Well, of course you won't get 2 because you'll divide by 0. But, right, like that's not the answer anyway. So the restriction's not really necessary. Like it's not necessary part of our solution to say x is equal to negative 4 as so long as x doesn't equal negative 3. Well, it doesn't equal negative 3. So, but I still think it's a good idea to add those restrictions. You can, if you do it in your head, that's fine, I suppose. But you want to kind of probably make note of them because it could turn out that the solution to this, if we just did the math, worked out to negative 3. And if that happened, then we say, oh, but it can't because of the restriction in the rational expression part. Right? So those restrictions from grade 11 now will come into play. Like if I was solving this problem and one of my solutions was in the restrictions, then it's not a solution. That's what a restriction means. If you think about the graph, it would be like a hole in the graph. X not equal to negative 3. There's a hole there. It's not true at that point, but it might be true everywhere else. But this ends up being linear, so it's only true in one place, not in our domain of restrictions, so it's not important. Does that make sense? Okay, and the idea of looking at the denominators, multiplying on both sides, is what we're getting out of this. Let's try another one. In grade 11, if you're doing something like this, your first step would be to factor the bottom. I don't actually, like in some cases you will do that. If there was other junk in this question, I would absolutely do that. But in this case, I don't have to. Okay? Because I can just multiply both sides by x squared minus 4x minus 21. So I'm going to get x plus 3 equals 1 times x squared minus 4x minus 21. Does that make sense? I didn't show it, but I multiplied both sides. These simple ones, you probably don't really need to show that step every time. Some of the harder ones down below, we will. But one thing I want to be careful of is that I don't know what x can't equal because I can't see the values in that trinomial on the bottom. So I'm going to go over here and sort of factor it. X squared minus 4x minus 21. And it works out to x minus 7, x plus 3, which is kind of sketchy because there's an x plus 3 on top, so there's something fishy going on there. But anyway, there's a reason why we're doing this. So that means x can't equal 7, and x can't equal, again, negative 3. Because if it did, it would have made the denominator 0. Is everybody okay with that? So now I can go ahead and solve this, what's left. And I'm going to move everything to the right. So I get x squared. Negative 4x minus another x is negative 5x. And negative 21 minus 3 is negative 24. And this is just a simple trinomial. And I believe it's x minus 8, x plus 3 equals 0. Does that look right to everybody? And so then my solutions are x equals 8 and x equals negative 3. Oh, but hold on. My restriction said that one's not possible. You don't have to say due to restrictions when you say, you can just say inadmissible, but due to restriction, right? So that's what it can sometimes look like. If we had factored, then we could have simplified by dividing out the x plus 1s, still thinking about the restriction. Then we would have had a linear and only got, like, you don't have to write this down, but maybe I'll do this again. Then we would have only got one answer, and it would have been x equals 8. So it would have kind of naturally taken care of itself. Sometimes that happens, sometimes that doesn't. So sometimes questions are organized in such a way that you have to be mindful of the restrictions to interpret your final answer. Is that pretty straightforward? Or what do you think? Any questions about that? Yeah. What do you mean when you carried over the 3? Yeah, it's negative 21 minus 3. Okay. So what if so you don't have to write this down, but what if I did, what if I factored it instead? So x plus 3 over x squared minus 4x minus 21, whoops, equals 1. So it'd be x plus 3 over x minus 7, x plus 3, right, equals 1. And then those can divide along with the restriction at this stage, x can't equal negative 3 or positive 7. But it turns out that won't matter. So I end up with 1 equals, and I'm going to multiply, let's see, it's 1 over x minus 7 equals 1. Multiply both sides by x minus 7. Okay, and then these are gone. And I get 1 equals x minus 7. Add 7 to both sides. 8 equals x. X equals 8. Same answer. The 3's gone because we divided it out. So and again, the restrictions are irrelevant now because our answer's there, right? So do you see how it worked out? Like in both cases, in one case I got an answer of negative 3, but my restriction told me that's not possible. And in the other case, when I factored and divided out the x plus 3 factor, then my answer just worked out. So as long as you're careful about restrictions, then it'll work out. So this is where I got to multiply by a common denominator, but we're not going to, like when you're doing fractions and it's like 1/2 and 1/3, well, a common denominator, that's 6 because 2 times 3 is 6. That's harder to do with rational expressions. So we're not going to worry about trying to actually like multiply and find a common denominator. We're just going to multiply everything by all of the denominators kind of thing. So I got to multiply by 3 and by x, 1 over x, plus 3 and x over 3 equals 3 and x, 5 over x, right? So if I just show it that way, my common denominator would be the product of 3 and x, so I just do it that way. And then I can, that gets rid of my denominator. The 3's are gone, the x's are gone. So I'm left with 3 times 1, which is 3. Tell me if I'm going too fast. X times x, which is x squared, equals 3 times 5, which is 15. Two of the original fractions had x on the bottom. One of them had 3. So if I multiply everything, I have to multiply both sides by the same thing. And I got to take care of all the denominators. There's common between 2 of them. The x is common between 2 of them, so I only need the 1x. But then I also need the 3. So I multiply every one of those terms by a 3 and an x. Just like if it was can I do this? It was like 1/2 equals x over 3. I'd multiply everything by 6 or by 2 and by 3. Multiply everything by 2 and by 3, right? Same idea. Now we're just going to solve. So I'm going to move the 3 over. So 15 minus 3 is 12. So x is plus or minus the square root of 12, which is plus or minus 2 root 3. Any questions? Chad? Yeah. Well, so if you don't state it, turns out the answer is not 0. So that's okay. Let's say 0 did work, and you didn't state it and then forgot to then go back and kind of check and say it's inadmissible, and you left it as a viable solution, then you would lose a mark because it's not. So it's not that you have to state the restrictions. You're absolutely right. X can't be 0, but it turns out it's not, so it's fine. You don't have to state the restrictions, but like I said, it's a good idea, especially if there's multiple of them. If X just can't be 0, you're probably okay in that situation, but if there's multiple of them, it's a good idea to list them just so you can double check afterwards. Okay. One more here. So what's my common denominator? I've got an x plus 2 and an x plus 3. So my common denominator would be the product of those. X squared plus 5x plus 6. But I don't want to multiply everything by that, right? So this is what I was kind of talking about. So I'm just going to multiply everything by x plus 2, x plus 3 times 2 over x plus 2 plus x plus 2 times x plus 3 times 1 over x plus 3 equals x plus 2 times x plus 3 times 1 over x plus 2. Okay, simplify 2x plus 6 plus x plus 2 equals x plus 3. I'm going to subtract 8 from both sides and add x to both sides. So actually I can just do this, these two x's. cancel each other. So 2x equals negative 5, and x equals negative 5 over 2. So my restrictions originally were x cannot equal negative 2 or negative 3, but no problem. Any questions? Yeah. I always think easier is like a matter of perspective. So if it's easier to you, like if you see a trick or a shortcut that you think will somehow shorten it or just make it easier for you to understand, by all means, go for it. If you get the right answer, then you're probably on the right track. It's rare that we make a mistake and still get the right answer. It's possible though, right? But I'm sure like you understand what you're talking about. So that would be fine, yes. But easier is a matter of relative perspective to every single person. And for this example, we certainly wanted to demonstrate how you would, like what you would do when you had multiple binomials on the bottom, right? So even if there was an easier way, it would have kind of defeated the purpose of this example for us. But sure, there would be, like anything, there could be lots of different, like little steps that you could do differently to get to the same answer. Any other questions? Okay, we're going to do one more, but we're going to do something a little bit different with it. What the heck? So you might want to just get a scrap piece of paper, and you can write that down if you want, but I don't know that you have to. What I want you to do is with the person you're sitting with, or if you're not sitting with somebody, you can move and join another group, like a group of 2 or 3 kind of thing. I want you to see if you can solve this, basically. Can you come up with an equation that would solve this? So I'm going to give you a few minutes to, if you want to copy it down, you can, and then start sort of brainstorming some ideas about how to set this up to solve it, and then we'll chat a little bit, and you can try again, and we'll chat a little bit, and you can try again, and we'll see if we can get to a solution. Yeah.
It's supposed to be that they're 2 different, so it's Ted can go with X hours, and then Ned can go with 10 hours more.
Yeah, that should be Ned. Thank you. Yes. Okay, everybody got that?